So I wasn't following that name, but I'm here today to talk to you about adventures in Node and Nest. Before I get started though, I gotta get my remote to work. So my name is Zackary Chapple. Principal architect for a company called Ultimate Software. They are based out of South Florida. I'm an Angular and a Web GE. If we don't know, then developer expert. I'm a part of a conference called NG Atlanta. So it's a conference based out of Atlanta, Georgia. And you can find me on Twitter, Instagram, GitHub, LinkedIn, all that. One of the cool things that the company I work for does is they have a process called there we go.
There we go. And basically what that process does is it brings you into the company as a family. One of the things that's very important to the company I work for is that we all behave and operate as a family. And it's something I wish more companies did because we end up doing a lot more things for each other than we do out of something that's a selfish intention. Something else about me is I love Hoguo. This is the Sichuan Hoguo. And I love spicy food. So if any of you want to make me really happy, let's get that, or we can get some xiaolongbao and we'll be okay. We've seen a lot of really good presentations today about how to build our Angular applications, right? Everyone had some amazing content to bring to us. And you think now that you have all this, you're ready to go out and build a fantastic application. You have everything you need, but not really, right? Because all of that is focused on the front end. And how do we actually get to the point where we can build an application that's fully functioning, gives us everything that we need? So this is the list of things that we're going to cover in this hour. Not that I'm going to go through all of these and read them off to you because you'll get to see them later on, but it's quite a bit, and we'll get started. And I know the moment you see this, you're like, I really want you to go through all this content. It's exactly what I need to wrap up my day. This is going to be the best hour of my life. But there's a couple things I'm not going to cover. It's very important to think about how we don't compare ourselves to other technologies and say, well, we're better than them, or we're not as good as them. It's more about what's the right tool for what you are trying to do, right? And the other thing I'm not going to cover is how to test or how to get test coverage. Because in reality, we don't have time to test anyway, right? We're too busy building features, so ain't nobody got time for that. So now I'm going to show you the world. What is Nest? So a lot of people, if you were trying to look up Nest on the internet, you're going to end up finding this. This is the Nest thermostat. Definitely not what we're going to be talking about today. Nest was created by a guy by the name of Camille out of Poland. And Nest is a Node.js framework that helps us to build scalable applications with TypeScript. I like to think about Nest as a baby. It's a baby of Spring, Angular, Node, and TypeScript. So if you know Java, you know Spring, you're going to be very familiar with what you get with Nest. If you know Angular and how it uses dependency injection, you're going to be very familiar with Nest. The way you get Nest, install the CLI, right? A lot of the stuff you've seen today is based on different CLIs. Nest has its own CLI. You just install it from NPM, you're ready to get going. So once you have your Nest application created, you can go ahead and start creating some Nest endpoints. And this is going to look very familiar to everyone who's been doing Angular and learning about Angular today, because you have the same concept of controllers and modules that you've been looking at throughout the day. And I was describing to the translator earlier yesterday about how do you explain the controllers and modules. And being a guy that loves food, I like to think of these as xiaolongbao. A module is a xiaolongbao. It encapsulates everything that's part of what you're trying to get across. And the controllers are like the roe. They're like the meat inside the xiaolongbao. And the more you start to unpack that analogy, it really works. And you'll see that as we go through. So the way you actually generate these is you can actually just use the Nest command line tool, and you can generate the module called users, and you can generate the controller called users, and it's going to put those in the correct directories. And actually, just like a lot of the other stuff that's based on schematics, it will modify the files and get them set up for you. So now that we actually have our controller, it's time to add an endpoint. And if you're familiar with Spring annotations, you can see that this get endpoint is very similar with what you would do with Spring. Right now it does nothing though, right? It just returns an empty object. We're going to add a little bit more to that as we go. A couple things that are interesting though is that there's actually more than one way to use, to return the values from your controllers. You could just straight return the value, or you can add a, right here, you can add a type on the response, and then you can use that to actually send the same way you would with like default express. So let's go ahead and add a little bit more interesting stuff to it. So one of the things that we could do is we could actually wrap a lot of the exceptions that we're going to be throwing for when we have some kind of random condition. So let's say, we have our username check here, and we're going to say, hey, you know what, something didn't happen the way we expected it to, so let's go ahead and throw an error, right? But those of you who have tried throwing errors in Node before know that that's a very not so fun thing to do because it'll crash your application. So that's why we add this little block right here to catch it. And that's going to allow us to send an HTTP response to the client and be able to give them an error that's a valid error without having to crash our server and then be able to have all the error handling we want. So now we have this return that's not really doing anything. Let's add a little bit of data persistence to it. So again, with that Shalom Bao analogy, we're going to start adding a little bit of the juice, a little bit of the water to our dumpling. And we're going to be doing that by injecting a service, right? So again, we're going to generate a service with the CLI, and automatically it's just going to add that service to our module. And what this service is going to do is we're going to have a function on there that's going to say find by username, because if we're going to try and get the username from the front end, we want to actually have our service be the one returning that. We don't want to put all that logic in our controller and begin to conflate things. So what's next? Well, I talked about persistence and using services, but that's not real persistence, right? That's just getting it to be persistent throughout your application in the front end, or in your API, but it doesn't actually save that to the database. So in order to do that, I'm actually going to leverage MySQL and TypeORM. TypeORM is a set of typings and a framework on top of Node that's going to allow you to generate the types on entities, and it will automatically go and scaffold those types into your database. So the way you add this into your application is actually really easy, right? So just like you would import a third-party module into your Angular application, you import that third-party module into your Nest application along with the different schemas. And you can see here that I'm using MySQL, but this works for Mongo, it works for all kinds of different databases, and it's really easy to use. And if you look at the part where it says entities down here, you can see that all it's doing is it's just grepping through these directories and picking up all the different entities that I have. So what is an entity, right? So this is going to be what's defining the shape of our database. And it has an annotation just like everything else we've seen, so that's going to make it really easy for us to use. And then it also has annotations that define what type of columns we have. And because this is a user's entity, we want to be able to combine our users with their roles, right? So we have our typings, we have a join, and then that combines with our roles entity, right? Now that we've done that, though, there's a little bit of magic that happens, because I didn't have to go through and set up my SQL database. When I start my Node server, it's going to go through, and if I had, on this part right here, if I have it set up to synchronize true, every time I start my server, it's going to go and update that schema for me. And so I don't have to go define that. I don't have to understand how SQL works. So now that I have this entity, I need to actually start using it, right? So I'm going to add that entity to my service module, or my users module, and now I can begin to actually leverage it in my service. So rather than having to figure out how to call my backend from my service, I'm actually just going to use TypeORM, and it gives me some really easy things to do, like save. I don't have to figure out how to write a statement to insert stuff into SQL. I could just do save. TypeORM takes care of that for me. And if I decide to switch to Mongo later on, I don't have to figure out how Mongo does it, because TypeORM does it for me. The same thing with the find, right? I don't have to figure out how to do a good select statement. TypeORM is going to handle all of that for me. But our users are not always the best, right? Sometimes they give us not what we're expecting, right? We're expecting cats, they give us an owl. It looks kind of the same, but not really, right? So how do we validate the request objects that our users are giving us, right? One of the principles that I like to live by is trust no one, especially the user. Another really interesting thing is that we can do is we can create data transfer objects. And one of the things that allows us to do is define what we're expecting to come back from the user. And in this case, for creating our users, I'm going to say, hey, I expect two things. An array of roles, it can't be empty, and a username. The nice thing about that is that in order to begin using this, all I have to do is add one line of code that says, hey, let's use pipes in all of our responses. And then when I have my post request for creating those users, all I have to do is on the post body, add a typing to it. And just by adding that typing and having the validation pipes, I get this wonderful response here that gives me everything I need to do to say, hey, you know what, this isn't exactly what I expected. That's going to make your life a lot easier when you try and do it. And then as time goes on, you're going to start adding different things to those data objects. You don't have to go through and write all of those error messages. This is going to create those for you. So now if you look at this, we have all of our controller done. We're using a service. It has good responses. It has good error handling. We're done. But how do we handle field level permissions? Because one of the things that might happen is you send something down to the user, but you didn't really want to send that to the user, right? You're telling them exactly what your secrets are. You happen to accidentally expose a user's password or something. Or maybe you're dealing with like HR information. You're revealing their identity card number, right? A user should be able to see their own identity number, but other users shouldn't be able to see it. In this example, I'm going to talk about Superman, right? Nobody other than Superman and maybe his parents should know where his hideouts are, right? You shouldn't be giving that to the user, right? You want to make sure you hide that out because the moment someone else at your company is going to see that, they're going to be like, no, stop, you shouldn't be doing that. And luckily there's something from Class Transformer that allows us to really easily handle that. And that's through the exclude and expose. So we could actually exclude the entirety of this class and say, you know what, we're not actually going to send this down to the client. We're gonna individually on a field level begin to expose those things. And the really nice thing here is you're able to decide who you expose it to. So you can say, you know what, only my admins get to see the hideout. Right? That's really advantageous. That's going to make it a lot easier for you to be able to control who sees your data and when. It's much better, right? We're able to really control everything that we want to send down on our API really easily with typings. File uploads. Who here has actually tried to write a file upload before? Like 5 people? Awesome. It's not always the easiest thing to do, right? Especially with Node, there's a million different ways to do it. 2 lines of code, right? 2 big things that we have to do. We have to add an interceptor for files interceptors, and we have a type of uploaded file. Literally, that's it. Now we have a file uploader. Handles all the chunking for us, handles all that fun streaming, and then all we have to do is just write that file or decide what we want to do with it, right? You're going to persist it to a database or write it to a file system. But that's the easiest file upload I've ever seen. The other thing we have to think about is pass-through APIs, because as we're building our APIs, we're not always the source of truth, right? We may have to call somebody else to get that information. We got to hand that data from their API to our API. And that's actually a really easy thing to do as well. Because we are able to use the response type here, we could actually just pipe that response back to our response object. So then that allows us to transfer their data straight through to our API. We don't have to handle the headers. We don't have to handle any of the complex logic around that. We can literally just pass that response through. Health checks. For those of you who write APIs, it's really important for you to have a health check on your API. That way you can know whether or not your API is actually up, right? You should be monitoring it. You should be paying attention to the status of your API. And health checks are actually really easy to do, right? It's just a GET response, and you make sure that you say, hey, this is how long my server's been up. This is how much memory it's using. You know, what platform am I running on? And you should have a status on it, right? But there's something else that you could do with your health check that I find really interesting is I also like to put the version of my application in my health check. Because one of the things I found as I deploy my applications to the cloud is you don't always have the version deployed that you expect, right? And being able to check the version on the API itself makes it much easier. And the way you do that is you can just literally pull the package JSON file, read it, parse it, and then put that as part of your response on your health check. A couple lines of code, you're able to get something that's significantly more valuable. Compression. I came here and I have 1 GB of data. That's it. Every website I go is murdering my phone. And bandwidth is not always fast. So we have to be cognizant of what our users' bandwidth is and how much data they have. So sometimes it's really valuable to add compression to our APIs, because you can see in this example here, I had a simple JSON object. We went from 6 kilobytes to 2.9 kilobytes. Data is precious. It took 1 line of code to begin using compression. That's it. It's really easy to do. You should be doing it. Authentication. It's really important to make sure that our applications are secure. And one of the ways I like to do that is by leveraging JWT. JWT is something I've been using at multiple companies. It's really easy to use. I'm not going to go through the actual implementation of this because it follows a lot of the same stuff that we've already been going through. And all this code will be made available at the end. But this is how you would set up the module for JWT. And then very similar to what we were doing with users, we're going to have a service. That server is going to have 2 different functions on it. One of them is the actual sign in, and you can see that we're using the same pattern for the login data transfer object, and then we also have a validate user, which will be used later on. And now we can actually inject that strategy that we created into our auth provider, which is through Passport. And the nice thing here is that we're actually creating an encrypted key, an encrypted token. That way people can't spoof our tokens and elevate their own privileges. That's going to be very important later on. And then also we're going to have that validate function here again. And then now what we could begin to do is we got to create our sign-in endpoint, right? So people need to actually be able to log into our application. That's, again, very similar control to what we had before. And now what that's given us the ability to do is actually leverage guards. So if you've been doing Angular for a little bit, you're familiar with router guards. Nest has the exact same thing. We have guards on our routes on our server. And adding in router guard is as simple as just using the annotation, saying which guard you want to use. And now all of this API is protected. You cannot get to this API without being authenticated. But sometimes I want to do more than just being authenticated. I want to make sure that a user is the right user that's able to use that API. And in that case, we're actually going to create another guard that has a can activate. Can activate is the same thing that you saw in Angular around being able to activate on a Angular route. The same thing's true for Nest. And what we're going to do is we're actually going to check the roles that a user has before we allow them to access that API. And then once we have that, we're actually able to add that annotation to our API with 1 line of code and say, you know what, this is only going to be available for admins. I don't want anyone else to be able to delete that. Logging is something else we should be able to do pretty easily, right? It doesn't get any easier than with Nest, right? They give us a custom logger that we can use, and all we do is just use this logger throughout our application. So if later on someone says you need to go from one logging platform to another logging platform, you don't have to change what you're doing throughout your entire application. You'll change it in one place, and that's the implementation of the logger. All of the rest of your code stays the same. Has anybody used GraphQL yet? Nobody. Okay, does anybody know what GraphQL is? Okay, good. I would have skipped these slides. Okay, so GraphQL is also really easy to add to our application. Just like using any other import, we could just import GraphQL. It's going to grep over the type paths looking for GraphQL files, and it's also going to go through and add that to our schema. And some cool things that you get with that is the ability to start using resolvers now. I switched from heroes to cats because those are 2 fun things to have. And you'll notice here that instead of having services and controllers, we have services and resolvers because GraphQL is fundamentally different than REST. okay? And the way it works is by using the resolver annotation, and then you have your queries, your mutations, and your subscriptions the same way that you do with anything else that's GraphQL based. And again, I'm not going to go through GraphQL itself. That's a completely different class, but this will show you how to implement GraphQL on Nest. Nice thing about that is we are able to have the similar injectors, and this time we're actually able to be able to leverage what the GraphQL services that are available by default. This is what our GraphQL definition would look like, right? So this is standard GraphQL stuff. And it also gives us this really nice dashboard to be able to test our GraphQL queries and be able to see what we would get as a response. That way you don't have to go through and build all your application out. You can begin to test it in the Explorer and have a little bit of fun there. So how do you test for scalability? Right, so a lot of us will go through and we'll write all of our application, we'll be ready, we'll ship it to production, 5 users get on it and it crashes. That's not a fun thing to happen, right? That doesn't make your users happy, it doesn't make your boss happy, and at the end of the day you go home crying a little bit because that's not what you wanted. There's a really cool tool that I started using a couple years ago called Siege. And what Siege allows you to do is to programmatically send requests to your server with multiple concurrent users and for different amounts of time and with different amounts of requests. And what you can see here is it's actually pounding my server with these requests, with the amount of users that I asked for, and it's going to tell me what percentage of these transactions actually made it through, how much time elapsed, how much data was transferred to the user. And this is very helpful information when testing the scalability of your application because you can actually see how well your APIs are performing. And you could actually scale this to multiple clients too, so you could actually, because your computer can't go over a certain number of concurrent connections, but if you scale this out to multiple machines, you can begin to really load test your APIs. Swagger. Has anybody used Swagger before? Fantastic. So Swagger is also available with Nest. And the way that we add Swagger to our application is we just add the document builder to our main part of our server code, and then we can begin adding annotations to all of our APIs. Personally, I feel this is incredibly verbose, and I don't like Swagger because I don't use it that much, but there is a lot of people who find value in it, and I figure it would be very helpful for us to see how to use that. Sockets. I'm going really quick, so we're actually going to be done a little bit early. But sockets are another fun thing to use, but it also can be a really good inundation of data. And sockets are also really easy to use on Nest. It's literally just a separate annotation, right, where you set up a socket gateway. It's going to leverage your server, and then you can begin to handle the different events that come into your application. And the use case that I had for this was I wanted to be able to stream logs back from my system, right? Every single user that's on your application has things that they're doing, right? There's routing events, there's click events, there's different things that they're doing in the application. And it's very helpful to be able to stream those logs back in real time and not have to batch them or have excessive HTTP requests, right? You could just have them on one single socket and just stream them to your server. But if we want to actually start using those, let's make them available through a service, right? Let's use the same type of methodologies we have for all the rest of our persistence. And when you start to do this, some really interesting things can start to happen. And one of the things that I want to show you is, actually the last thing I'm going to show you, is if you remember from our health check, we were giving stats on our memory usage, we were giving stats on our CPU percentage, as well as the version of our application. Because we have this live stream of sockets coming back for every single user, and we have a service that's persisting that as an observable, we could actually watch that on our health check and be able to, on the health check, monitor how many concurrent users we have. And that's really helpful. You don't have to pay for that. You don't have to be using some third-party service to be able to check that. You could actually know that on your API itself. That's all I got for today. Thank you guys very much. Join my group if you want to chat and ask any questions. I blew through that talk. That was a little bit faster than I was expecting. But let me know if you guys have any questions. Thank you.